C, the brainchild of Dennis Ritchie at Bell Labs in the early 1970s, emerged from the desire for a portable and efficient language to develop the Unix operating system. Prior to C, systems programming often relied on assembly language, which was highly machine-dependent and cumbersome for complex projects. C provided a higher-level abstraction while retaining the ability to interact closely with hardware. This combination of power and portability proved revolutionary. The influence of C on the landscape of programming languages cannot be overstated. Its syntax and core concepts, such as structured programming and modularity, became the foundation for numerous other languages, including C++, Java, C#, and many more. Even today, with the advent of countless modern languages, C remains a cornerstone of systems programming, embedded systems, and high-performance computing. The creation of C marked a pivotal moment in the history of computing. Its impact continues to resonate today, shaping the digital world we inhabit. Why, in an era of high-level languages and rapid application development tools, does C remain so relevant? The answer lies in its unique combination of low-level hardware access and high-level abstractions. This duality makes C an ideal choice for a wide range of applications, even in the modern software development landscape. Operating systems, the very foundation upon which our computers run, often have their kernels written in C. Its ability to manage memory directly and interact with hardware makes it a natural choice for this critical task. Embedded systems, found in everything from cars to household appliances, also rely heavily on C. Its efficiency and small footprint are well suited for resource-constrained environments. Moreover, C's performance characteristics are unmatched by many modern languages. When speed is paramount, such as in game development, high-frequency trading, or scientific computing, C often emerges as the preferred choice. Learning C, therefore, is not merely about mastering a language, it's about gaining a deep understanding of how software interacts with hardware. At the heart of any C program lie variables, the containers that hold the data our programs manipulate. C requires that we explicitly declare the type of data a variable will store. This might include integers, int, floating point numbers, float, characters, char, or more complex structures built from these basic types. Data types ensure that the compiler understands how much memory to allocate for a variable and how to interpret the bits stored in that memory location. For example, an integer variable might occupy 4 bytes of memory, while a character variable might only require 1 byte. Operators, the symbols that perform actions on data, work in conjunction with variables and data types. Arithmetic operators like plus, minus, multiply, and divide handle mathematical calculations, while comparison operators such as equal to, not equal to, greater than, and less than compare values. Logical operators including and, Oregon, and not combine or modify Boolean expressions. Understanding these fundamental building blocks is essential for writing even the simplest C programs. The ability to control the flow of execution is fundamental to programming. If statements allow our programs to make decisions based on conditions, we can test whether a particular expression is true or false and execute different blocks of code accordingly. Loops, on the other hand, provide a mechanism for repeating a block of code multiple times. The for loop iterates a fixed number of times, while the while loop continues executing as long as a certain condition remains true. These control structures empower us to write concise and efficient code for repetitive tasks. Imagine writing a program to calculate the factorial of a number. Without loops, we would need to write separate multiplication statements for each possible input value. With loops, we can express this logic concisely and elegantly, handling any input with ease. Section 5. The power of functions. Functions are the building blocks of modular programming in C. They allow us to encapsulate a specific task or calculation within a reusable block of code. This promotes code organization, readability, and maintainability. Functions can take arguments, which are inputs, and return values, which are outputs, allowing for complex data processing. By breaking down a large program into smaller, well-defined functions, we can manage complexity more effectively. Each function can be tested and debugged independently, making the overall development process smoother. Moreover, functions promote code reuse. For instance, if we need to calculate the factorial of a number at multiple points in our program, we can define a factorial function once and call it whenever needed. This avoids code duplication and makes our program more efficient. Section 6. Exploring arrays and pointers. Arrays and pointers are two powerful concepts in C that allow us to work with collections of data and memory addresses directly. An array is a contiguous block of memory that stores elements of the same data type. We can access individual elements using their index, which starts from 0. Pointers, on the other hand, hold memory addresses. They provide a way to indirectly access and manipulate data stored in those addresses. Pointers are particularly useful for working with dynamically allocated memory, where the size of the data is not known at compile time. While pointers offer great flexibility and control, they also introduce potential pitfalls. Incorrect pointer manipulation can lead to memory leaks or program crashes. Mastering pointers requires careful attention to detail and a solid understanding of how memory is managed in C. Section 7. Best practices for clean and efficient C code. Writing clean, efficient, and maintainable C code is crucial for any programmer. Several best practices can significantly enhance the quality of your code. First and foremost, strive for code readability. Use meaningful variable and function names and add comments to explain complex logic. Indent your code consistently to improve visual structure. Break down large functions into smaller, more manageable ones. Minimize global variables to reduce the likelihood of unintended side effects. Validate user input to prevent unexpected program behavior. By adhering to these practices, you'll create code that is not only functional, but also easy to understand, modify, and debug. Remember, writing good code is not just about making the computer understand your instructions. It's also about making your code comprehensible to other programmers and your future self. Section 8. Resources for your C programming journey. Embarking on the journey of learning C programming opens up a world of resources designed to guide you. The definitive guide, often referred to as the K&R, is the C Programming Language by Brian Kernighan and Dennis Ritchie. Online platforms like Code Academy, Coursera, and edX offer interactive C programming courses. Websites like Stack Overflow provide a forum for asking questions and finding solutions to coding challenges. Don't hesitate to explore open-source C projects on platforms like GitHub to learn from experienced programmers. Remember, the key to mastering any skill, especially programming, is consistent practice. Write code regularly, experiment with different concepts, and don't be afraid to make mistakes. Every error is an opportunity to learn and grow as a programmer. Section 9. Conclusion. C, though a language with a rich history, remains profoundly relevant in today's technological landscape. Its unique blend of low-level control and high-level expressiveness continues to empower programmers across diverse domains. From operating systems to embedded systems, from game development to high-performance computing, C's influence is undeniable. Mastering C programming is a rewarding endeavor, providing a deep understanding of how software interacts with hardware and opening doors to a wide range of career opportunities. Embrace the journey, be persistent in your learning, and the power of C will be at your fingertips.